At a combat weight of 69.8 tons, the King Tiger, or Tiger II, was built to shatter enemy lines as the offensive spearhead of the German armored forces. Looking at this diagram, we can see exactly how massive it was. Measuring nearly 34 feet long with the main gun extended, the King Tiger completely dwarfs Allied heavy tank counterparts like the American M26 Pershing and the Soviet IS-2. To survive breakthrough operations in heavily defended enemy territory, the tank required a defensive architecture capable of withstanding direct, high-velocity kinetic strikes from multiple directions. The engineers achieved this defensive supremacy through a precise matrix of geometric sloping, interlocking steel joints, and strict internal survivability protocols. For the King Tiger, armor functioned as a calculated system designed to ensure the machine and its crew continued the mission, even under direct fire. The foundational core of this system is the 5-man crew, the central package the armor is designed to protect. The driver and the radio operator sit in the front section of the hull. Above them, in the turret, the commander sits behind the gunner on the left, with the loader stationed on the right. The defensive envelope begins beneath them. The front floor plates of the hull are constructed from 40mm steel. This specific thickness was chosen to shield the driver and radio operator from the upward blast of anti-tank landmines. Moving to the rear section of the floor, the armor thins to exactly 25mm, concentrating the vehicle's weight and heavy protection precisely where the crew is most vulnerable to ground-up threats. The tank's survivability design starts at ground level, mitigating environmental hazards before it even addresses the threat of enemy armor. The primary shield against enemy fire is the upper glacis plate on the front hull, constructed from 150mm of hardened steel. This diagram shows the geometric calculation making the armor so effective. Tilting the steel plate at a 50-degree angle increases relative line-of-sight thickness to 213mm. Because of this, there are no recorded instances of the front upper glacis being penetrated in combat. Below it, the lower glacis plate measures 100mm thick and maintains that same 50-degree slope. To connect these two plates, Henschel engineers utilized complex interlocking joints, which minimize structural weakness at the seam. This ensures the entire front hull behaves as a single, rigid unit under extreme kinetic stress. The frontal hull operates as a masterpiece of relative thickness, proving that applied geometry provides superior protection over the raw weight of the steel. Above the hull sits the Henschel turret. Its front face is built from 180mm of steel angled at 10 degrees, creating a relative thickness of nearly 183mm. The sides and rear drop to 80mm of armor. The turret's overall elongated shape acts as a counterweight to balance the massive 88mm main gun. Protecting the base of that gun is the Saukoff, or pig's head mantlet, cast with a maximum armor thickness of 150mm. Looking at this detailed illustration, we see how the elongated, curved casting is engineered to deflect direct strikes away from the internal mechanisms. This curvature forces shattered shell fragments outward, preventing debris from jamming the turret's elevation gears and rotation ring. The focus on mechanical reliability and crew survival extends to the hull hatches for the driver and radio operator, which feature a specific lift and rotate design. The engineering intent here is mechanical leverage, allowing even a severely wounded crew member to force a jammed hatch open for egress. The turret and hatch designs balance the demand for massive frontal protection with the mechanical necessity of moving the weapon and escaping the vehicle. Inside the vehicle, the most significant threat to the crew is the 22-round ready rack located at the rear of the turret. If an enemy shell manages to penetrate the thinner 80mm turret sides, striking this rack would trigger a catastrophic ammunition cook-off. To mitigate this, crews developed a protocol to keep the ready rack completely empty during combat, relying instead on the 48 shells safely stored deeper inside the hull walls. They also mounted heavy spare track links on the exterior of the turret to act as spaced armor, adding an extra layer of protection to the vulnerable sides. Defensive supremacy required crews to manage their internal hazards with the exact same rigor they applied to external threats. By combining advanced geometry with nearly 70 tons of steel plates, German engineers successfully created a statistically impenetrable frontal arc. The fatal trade-off for that protection was an immensely overstressed drivetrain. The system powering the tank was originally designed for the Tiger I, a vehicle 10 tons lighter. The raw torque required to move the King Tiger's weight, over 1,360 pound-feet, routinely sheared the teeth off the drive sprockets, causing the final drive system to fail after an average of just 186 miles. As a result, a massive number of King Tigers were never defeated by enemy fire. Instead, they were abandoned in the mud and blown up by their own crews after breaking down during a retreat. The King Tiger's armor plates reliably protected the crew from kinetic strikes, but the crushing weight of that very protection ultimately crippled the tank's ability to fight the war.